Now our second topic is angular torque. As in our previous video we have discussed about the torque, now we are going to discuss about the angular torque. That what is angular torque? As the formula of torque is T is equal to Rf sine theta. Now the theta, which angle will come here, as this is a cross product, so the torque is formed on a 90-degree angle. Like for example, this is a circular path. Now this is the radius of it. Now for example, this is any velocity. If a body will move in a circular path, first of all it will move upward so that it can move in a circular path, so it will make a 90-degree angle. Now it reach here, the body reach here. Now for turning it will move on that side, so it makes a 90-degree angle. So that torque basically the torque forms on the 90-degree angle. So here the torque will be on 90-degree, so it will be sine 90-degree. Now sine 90-degree is equal to 1, so we are not gonna write here. So it will be torque is equal to that position vector into force. Now force, what is the formula of force? Torque is equal to, we can write ma, because force is equal to mass into acceleration. Now acceleration is equal to, as this is the linear acceleration, and now we have to find the angular acceleration. So the formula for the angular acceleration will be radius into this one acceleration, so that will be angular acceleration. So we are going to put the value of that a here. That will be T is equal to R M, and here a, the value of this R alpha. Now this alpha is basically angular acceleration. Now this is when R will be m r square and alpha. This mr square is basically a moment of inertia. This is moment of inertia. Now what is moment of inertia? This mr square is basically a moment of inertia. For example, what is moment of inertia? The body moving with a angular mass in a circular path, that is known as, for example, like if a body is moving in a circle, if there is a body which is moving in a circular path, if a body is moving in a circular path with the angular mass, that is known as moment of inertia. Like the moment of inertia, the moment of inertia is also known as rotational inertia, as well as angular mass. That are the another names of that moment of inertia. So what is moment of inertia? Like a body is moving with a circular mass or the angular mass, that is known as moment of inertia. Now moment of inertia is denoted by I, and that is mr square. Now here as angular torque, that is T is equal to mr square alpha. So can we write here I, that is moment of inertia, instead of this? So we'll be writing here T is equal to moment of inertia into angular acceleration. So that will be known as angular torque. That will be known as angular torque. Angular torque and Newton's second law, they both are like same. Like because the Newton's law shows the linear motion, like all the things in the linear motion, like that it shows ma, the second law. that is linear, that mass is linear, acceleration is linear. In angular torque shows that angular motion, like here as angular torque we have made a formula, that is this is angular mass and this is angular acceleration. So that is both are same formulas, but this is in a linear motion, this is in a angular motion. So we can also say that angular torque and Newton's second law both are same. Now starting another topic, that is angular momentum. What is angular momentum? Basically angular momentum is denoted by L, and what is it? The product of position vector that we show as R and a linear momentum that we show as P, that is known as angular momentum. What is it? The product of position vector and linear momentum is known as angular momentum. So as angular momentum, if you want to make a formula, angular momentum is L, the product of position vector and linear momentum, that is the formula. So here momentum is equal to P is equal to mv, so that is the formula of momentum. So we can also write here r into mv. Now this velocity is basically a linear velocity. So what is the angular velocity? It will be v is equal to r omega, that is the angular velocity. So we will be putting its value here, that is L is equal to r m, same here, velocity, instead of velocity will be putting radius omega. So that will be its now will be summing like r square, that will be mr square omega. Now mr square, as we studied that mr square is a moment of inertia, so here we can write I as well. So the angular momentum is equal to moment of inertia into omega. So that is the formula for finding angular momentum. Now if we talk about its unit, now how can we calculate its unit? The formula is I into omega. What is the unit of moment of inertia? That is mr square. M is kg, r means meter, and it is a square, so it will be square. So the unit of moment of inertia is kg meter square. Now what is the unit of omega? That is the angular velocity, that is radian per second. Now radian per second, we can radian we are not considering a radian, so we write here kg meter square upon second. So this is the unit of if we talk about its rotation, the angular momentum rotation. So if a body is moving clockwise, so the angular momentum will be in inward direction, and if the rotation of a body is anti-clockwise, so the angular momentum will be outward. And if we talk about that which quantity is it, it is a vector quantity. It is a vector quantity. So that was the angular momentum. The product of position vector and linear momentum is known as angular momentum.